Hello class, this is an example of a confidence interval for a mean. So in this example it says a poll asked a national random sample of 515 adult women to state their current weight. The mean weight in the sample was 152, and we will treat these data as a simple random sample from a normally distributed population with standard deviation of 36. From here, we want to calculate a 90% confidence interval for the mean weight of adult women based on this data. So the first thing we want to do is we want to start pulling out ideas from each part of the data of this scenario. So here we have a poll of 515 adult women, okay? We have a sample mean of 152 and a sample or a population, so population standard deviation of 36. And so if we want to write that in symbols, we have then x bar is our sample mean equal to 152. Our sample size, n, is equal to 515 adult women sampled, and sigma is equal to then 36. That is our population standard deviation. So to calculate a confidence interval for a mean when we know the population standard deviation, we calculate x bar plus or minus a z critical value times then our standard error, which is sigma over the square root of n. So far we have all of our values except for z star. So how can we find this? Well, recall these are standard levels, and so basically from our notes we find that for a 90% confidence interval, this critical value will be equal to, this is only when we know our population standard deviation, this will be equal to 1.645. If we think about that, what that means is essentially, if we look at the normal distribution, this is the cutoff where our middle data is 90%, and out in the tails we have a total of then 10% of a z distribution, so a standard normal distribution. So these are then our two cutoffs, negative 1.645 and a positive 1.645. So that's where we get those critical values from for a 90% confidence interval. I'm going to go ahead and just erase this part real quick. So now that we have all the values that we need in order to construct our confidence interval, all we need to do is just plug them in. So essentially we have 152 plus or minus our z critical value of 1.645 times the standard error, which is then equal to sigma 36 all over the square root of our sample size 515. So go ahead and plug in those things. Let's calculate the standard error first. So that's this section right here. Carry everything else along. That's going to be 152 plus or minus 1.645 times then 36 divided by the square root of 515 is 1.586. And I like to carry things to 4 decimal places until I get to the very end. So 1.5863 is then my standard error. Now I should calculate my margin of error. So my margin of error is always my critical value times the standard error. So here my confidence interval is made up of my point estimate 152 plus or minus then my margin of error. If I multiply these guys together, then I get 2.6095. And I'm almost done with my confidence interval. If I add my margin of error and I subtract it, I then get a 90% confidence interval of a lower bound of 149.3905 and an upper bound of 154.6095. 0.95. So this is then just our 90% confidence interval for the average weight of adult women in the US. So how can I write that up? How can I interpret that? Well, again, we need to set up our confidence level or state the confidence level. So here, the 90% confidence interval. Then I need to tell the parameter that I'm estimating. So the average weight of adult women in the US, that's the population parameter that I am trying to estimate, is from 149, and I might round this to 0.4 pounds. So 149.4 pounds to 154.6 pounds. With a point estimate of then my sample mean, 152 pounds. So essentially, whenever we do an estimation, we want to give an interval estimate, that's the confidence interval, and a point estimate. So our confidence interval is always based on a level of confidence, in this case that's 90%, and our standard error and sample size, which is really good to give the interval estimate and then the best guess or point estimate. Hopefully this video helped you understand how to do a Z procedure for estimating a population mean.